Again, my name's Kent Brake. I'm a solutions architect here at Elastic. I've been at Elastic for about 5 years. The last about a year and a half, I've been supporting the Department of Energy. And in that function, I've had a chance to get to know a bit about the high performance computing workload and how Elastic's been used in that environment. So I want to share a few bits of that today and kind of give you an overview of why folks in the Department of Energy and other HPC organizations chose the Elastic Stack, how they use it operationally. Then we'll transition towards the end into how do you do data science off that data. So usually the end customers, the academics that are running some of these workloads on the HPC platforms, they do like to know how those workloads performed. And they do that data science usually through different tools, and we'll talk about those tools towards the end. So some of the challenges that I see at HPC environments, really the custom sort of monitoring points, GPU monitoring points, InfiniBand sort of network backbones. There are really custom pieces that make the HPC stack specific, but on top of that, there's really more complexity because HPC systems normally don't stand alone. The same folks that operate the HPC platforms also operate bespoke normal platforms, and the two systems work together. And so for these groups, they actually have even more complexity they have to manage. And with the new toolkits that are being used, mostly on more traditional platforms, things like Kubernetes and Docker, sort of the way the workloads are getting distributed way down deep throughout the HPC infrastructure, that's adding even more complexity in trying to manage and keep uptime at a high level. And if you take it from how organizations are usually segmented, the data that these systems produce really have different needs that different personas have inside the organization. So for the developer team, they need to know, is the workload actually meeting the features? From a service monitoring perspective, the SLA of that application is going to be really important, as well as the underlying infrastructure, the HPC physical hardware itself. And then the security team has got to keep all those systems secure too. So it really, typically they have different toolkits around what mostly is the same sets of data, and it's really not much different in HPC relative to distributed systems when it comes to that organizational complexity. And really, if you kind of think about it, or the way Elastic thinks about it, there's a lot of different ways that applications and systems are monitored. We kind of break it down in a few different ways. One way is just thinking about streaming logs. Another is the metrics that a systems produce. And then you have the abstraction layers, whether it be VMs or Docker containers or the actual orchestration infrastructure like Kubernetes. All of these pieces have to fit together in a seamless way, and they have to be monitored in a much more detailed fashion than was when things were just traditional hardware, traditional on-prem services. Elastic's been trying to break down all of these different silos by building a platform. So all of these different toolkits, the different tools that folks have been using that center around that operational use case and security use case, Elastic's unified that. And if you're like me and a guy who's been around, if you joined a couple minutes early, I've been doing systems level stuff since the late 90s. And this typically was my screen, where I had consoles for all of my different systems, lots of different tools, just to get the one operational picture of looking for service health. And we think, Elastic at its core is a search company. Observability, essentially monitoring these HPC systems, is a search use case. So we've taken a search approach to it. We've combined all of these different systems level data, the metrics and the logs, together in one unified platform with different views on the data for different teams. So the infrastructure folks can look at it from an infrastructure view, security folks can look at it from a security view, and so on. that unified interface can give you the things that really matter. So, the KPI summaries, is my systems performing relative to the SLA that I've signed up to? And if they're not, can I do root cause analysis without swivel chairing, without going somewhere else? And that's the core driving force behind our UI. And to make it more unified, to lower that operational burden, there's so much data coming in these days that machine learning, essentially using machines to look at machine data, to look for anomalies instead of putting eyes on it from a physical perspective every time, is really imperative. And Elastic's tried really hard to make that not only an easy button, but also scalable. And so we have operational systems throughout the DoD and Department of Energy that leverage ML from an operations perspective. And it's we think it's one of the solutions that really sets Elastic apart, in that we are the repository for lots of that monitoring data, and the machine learning is embedded right next to that data. And then once you have your data modeled, your systems essentially harnessed for metrics and logs, you really want to alert when anomalies do occur, when systems outages do happen. So we have a unified interface around alerting. So all of those different data sources pouring into one platform is really what Elastic's about. And if we break down really from an HPC perspective, as I mentioned before, there's really kind of two categories of data when you talk about monitoring. And the first is logs. Logs are really different from metrics in that they're a chronological series of events. Metrics, on the other hand, typically are running every minute, every 30 seconds, and are capturing numerical information, CPU utilization and the like. Logs, on the other hand, are saying, hey, this application started with these operators with this user ID at this point in time, and then it shut down at this point in time. And Elastic's been used for logging for quite some time. That was the way I was originally exposed to Elastic before I joined. So back in the early 2010s, the stack was born, and right from the beginning, Logstash was a component that was used to ingest data and turn the search engine into a logging application. And it's moved quite quickly since. We've added FileBeat in the Beats line of data shippers. These are little embedded agents where if you're pulling in via syslog and you don't have any applications actually running, maybe you're just doing flow models or the like on your HPC platform, maybe you wouldn't use Beats. But if you're producing data from an application, it's a great way to just to grab things that would normally be just dropped into a file, lift those up and have them brought into the Elastic Stack. And we added the capability to take streams of data that are known from like known applications, MySQL databases, Apache web servers, that, Cisco firewall logs, these sorts of things, and make them built-in modules to where they come with the dashboards, they come with alerts to give you that operational capability right out of the box. We extended it because folks were having a lot of success with Elastic. They were putting Elastic in a lot of different environments. We actually created an orchestration framework that would sit around beside Elastic to help people deliver the Elastic components in a more operationalized way. Things like rolling upgrades and incremental automatic snapshots and the like that are automated. And then in the last couple of years, we've really focused on taking that long tail of data and doing the best we can to make it as optimized from a hardware cost perspective as possible. And I'll talk about that in depth a little bit later, but the real banner level sort of features that has been introduced lately into the stack is moving as data ages through the platform. Operational data usually becomes less and less useful. And so sometimes you have compliance. A lot of times the scientists will want to do data science on it. So they'll want to keep that data around, but it's not always cost effective to do that on normal hardware, or SSDs and things are involved. It's a lot better to take a petabyte, put it on some old spinning disks. Maybe your queries won't run so fast, but they will be operational capable, and you can do that science on that data in a cost-effective sort of way. And we call that our cold and frozen tier architectures. We've also made a lot of investments over time in how we're displaying the data. So as we added the modules, we actually created an interface that's bespoke around operations, and I'll be giving a demo of that in just a second. But just to see the logs interface and how it looks today, as you can imagine, streaming logs from many, many systems, it's great to be able to see a holistic view. Being able to search, though, and pin down which application or which point in time is really important. And this is what this logs interface is supposed to be presenting to. Now we'll change gears and talk about metrics, and then we'll talk about correlating those two right after in the demo. So metrics themselves, as I said, in the difference of logs, where logs are per event, per log line, metrics usually are periodic, running every 10 seconds, every 30 seconds or like. They're grabbing typical KPIs like CPU utilization, number of current logged in users, these sorts of integers typically, and they flow over time. Elastic's had a metric store right from the beginning. It has been optimized incrementally over that time. It started out by adding a columnar store for the data scientists out there that are really interested in how data is stored on disk. We do have a columnar store right next to our TF IDF index for search. And that allowed us to build aggregation frameworks. And in building those aggregation frameworks, noticed that we could make some enhancements performance-wise. So we did some of the deep science. If you guys want to look up the paper around BKD trees, it's a really interesting probability-based data model. And we moved our metrics into that structure to speed up aggregations over time. And then we realized that over time, typically data that was coming in at high granularity, maybe you're pulling in every 10 seconds, maybe when that data is a month old, maybe it should be rolled up maybe every hour. So you can shrink that data down on disk and you can just get that summary data. And it's a feature we called roll-ups, and we created that back in 2018. We've also been incrementing on our infrastructure solution since then also. And really the main thing I want to emphasize is Elastic's engineering velocity. So for HPC built infrastructure, Elastic moves at quite a clip. We release point releases about every 2 months, majors about every annual year. But most of the time, the point releases are, for most companies, from a feature perspective, what a major release was. So 7.13 was released today. I encourage everybody to go check out some of the new features in it. But again, main point here is that our metric solution has been moving and being invested in over time. And we've created a pretty significant velocity that today, I think, ends up being squarely put for HPC metrics. From my work across the DOE, Prometheus is a very popular agent for grabbing metrics from HPC systems. And I found that a lot of folks weren't aware that Elastic integrates with Prometheus right out of the gate. So there's no need for other agents or agents on the machines themselves. The Elastic metric Prometheus integration runs in a unit called MetricBeat. At MetricBeat, you can talk directly to Prometheus servers running on the endpoint, or the Prometheus server as an aggregation point. So you can also integrate at the top level too. So very important. If you don't get anything else out of this talk, remember that you can be pulling your data from Prometheus and correlating your logs with Elasticsearch, and those two things work right out of the box. So we'll show you that infrastructure UI around metrics in just a second. But before I do, I want to touch just a little bit deeper on machine learning and why it's important. In an HPC environment, just like every other environment, we're scaling out. Systems are getting bigger. Being able to manage these different data streams, understanding what alerting thresholds for what data stream, and getting that inherent knowledge is just hard. Data streams are being added and removed quite quickly. Knowing what's a high level threshold alert that you need to do relative to what's steady state is a hard thing to gain insight to, and it costs a lot operationally to keep adjusting hard-coded thresholds. So machine learning for anomaly detection, which is our primary feature in the Elastic stack, really tries to focus on that. And I'll show you guys that in finer detail in the demo section in just a minute. But we have kind of two ways we learn from an unsupervised perspective. Because you're putting your logs already and your metrics already in Elastic, the data is already very close to the algorithms. And then Elastic doesn't ask you to pick the model for a given anomaly detection system, Elastic actually automatically picks the model, does a best fit sort of behavioral analysis on the models themselves. So it's constantly selecting what's the best model for this data. And it really does a great job of understanding the seasonality of data and being able to alert on outliers. All right, so that's enough of slideware. I think I killed you guys with slideware for 15 minutes. So let's pivot over and see what I'm talking about from an interface perspective. So when you're getting your data out of an HPC system, when you just initially install the Elastic Stack, very first thing is how to get it in. So this is Kibana, which is our UI interface that sits on top of the Elasticsearch data backend. And in its home screen, you have an add data area. And this gives you all of our pre-built integrations. So everything that you can bring in from the different applications that already come with dashboards. A lot of them come with alerts and machine learning jobs themselves, but it's quite an extensive list of data sets that are already pre-built for Elastic. But lots of folks in HPC you're doing science. A lot of times you have custom applications, custom logs that you need to visualize right around your metrics. And Elastic's been building toolkits to try to make that a little bit easier. So a lot of folks aren't aware, but hung off of the machine learning tab under the analytics subsection, there's another way to bring in data. If you click on the data visualizer under the experimental mode, there's an import data tab. And when you select that tab, you actually have got a pretty powerful way or different ways to bring in different formatted data. So we can bring in data that's just new line delimited text files, CSVs, new line delimited JSONs, and any really common format with a timestamp, even if it's a multi-line form, this data visualizer will try to parse that out for you. So just to give you a little example of that, I've got a little sample CSV file. It comes with a header. So just to pull that in, you'll see that, my font is really little. Let me make that a little bit bigger so you can actually see what I'm doing here. You'll see the very first line of that file, it had a header, and Data Visualizer was able to understand that it was a header delimited, found the delimited format, and it can explain how it did this analysis. It uses machine learning underneath to find the delineation in these fields. And then once it's done this analysis, you can actually override those settings if you'd like. And it gives you a great amount of detail to be able to customize how the data is brought in. Once you've got the data brought in, of course, you can import that data, save it to an index, and then now it's live in the system. So yet another way. And then once that data is brought in, say if that CSV file was continuously being written to, you can see here what Elastic actually did to create that configuration for that data. And so essentially you can just drop that configuration in the file beat and be able to consume that CSV file over time in an automated fashion. So once you have the data into Elastic, your HPC system, really the next tab that is the most important is the Observability tab. Again, that's system monitoring, metrics and logs for HPC systems monitoring. We just labeled as Observability as it's kind of a broader industry term. If we look at the overview screen, I'll bring this font down just a little bit so we can get a little bit more graphical in its presentation. You'll see really we break it down in a few subsections. First is the logs themselves, the metrics we're bringing in. In this demo platform, not super relevant for you guys, but we also have application performance monitoring. So if you guys do have scientists or web developers writing web front ends, we do have things that you would buy from, say, New Relic or App Dynamics actually built into the stack. We also have an uptime platform. So if you need to test your endpoints, maybe your service and REST APIs, and you need to make sure those services are available, you can do that in an active interrogative way, saying, hey, go hit port 80 or port 443, do a get, make sure I get data back, plot that over time, and alert if it doesn't come in inside of a threshold. That's also part of the platform, as is user experience and real user agent. But if we look at things that are really pertinent from a HPC platform perspective, you saw earlier we had this logging app. There's a couple of key features that I'd like to call out in the logging app. First and foremost is the ability to search. So just like every screen in Elastic, we are a search application. So being able to do search in a type down sort of way, as easy as pie, that is really the core feature of the stack. Searching over time is going to be important. But for systems folks, most of us are really used to doing that ~F right on the platform. So if you wanted to do that, the analogous way of doing that is just to stream the data. And as you can see, new events will be streaming underneath. We also have a histogram of how fast the events are coming in from a velocity perspective. Combining that with search and then the ability to get context from around events in action, give you that actionable way of looking at your log data. But you don't always want to look at it. Maybe you want the data to tell you about anomalies. And this is where Elastic's anomaly detection comes in. So by default, we've got machine learning jobs that will first alarm on rate. So how many folks here go to troubleshoot and the worst nightmare happens where the system goes down, system comes back up, you go try to figure out why the logs haven't been flowing in for a week, 2 weeks for that specific service. So you have no idea why it went down. With one click of a button, you can get the rate notification coming straight out of the machine learning where it learns the rate and what's an anomalously low rate and will alert when you get an anomalously low rate on an overall stream or a bespoke stream. And then kind of the third action, I think is really important to HPC users, that syslog stream that's coming out of these HPC platforms, that really noisy, hard to categorize stream. It's full of great data, but trying to understand that data really takes a lot of time to understand what's the frequency of the different messages and what's anomalous in them. And Elastic really uses some special sauce, a couple of things together to be able to do that automatically for you. One is the machine learning algorithms, the ability to track rarity of an event over time. And the other is Elastic's ability to do fuzzy search. And we couple those two to do a really novel thing. We take that unstructured syslog stream and we categorize it into buckets using those fuzzy search and some little bit of special sauce. You can see some of these buckets here where you see these categories. This is on a Java logs. So you can see how lots of the integers are pulled out and it's normalized. Then we track those buckets over time and how often the machine learning algorithm sees them. And when something bad happens, InfiniBand switch saturates, you lose a NVIDIA card on a node, that syslog stream is going to have a lot of messages that are going to be new and they're going to be uncommon. And it's going to just alert right out of the box. You don't have to do anything. You didn't set up any specific alerts for that event. You're just going to have an anomalous category on that stream at a high velocity rate. And that's going to be your trigger to go investigate. So a very, very high value feature. We do expose a lot more when it comes to machine learning. We do have a way to create machine learning jobs by yourself manually. We work real hard to keep that machine learning job ability kind of the easy things to be easy. So we have widgets for simple metrics and simple averages being high, these sorts of things. And then we have different wizards as you get a little bit more complex. Say you want to track multiple metrics, you want to bucket it on error messages, looking for anomalies by error message, things along those lines. We do have separate UIs or separate wizards for those, trying to keep the easy things as easy as possible and the hard things at least possible. So that's a good bit about how operationally you would look through our operations interfaces. Now, HPC systems, there are going to be asks from lots of different corners of the business and organization. Folks need higher level rollups. They need different bespoke information sets or infographics that aren't built into the Elastic interface by default. And we make those visualizations possible through our Analytics tab. So you can create visualizations of your own through this Create Visualization framework. We have lots of different ways to create them. Lens is probably the preferred application. Reason being, it's real easy to get started with. It's drag and drop capability. So if we just want to look at, say, one data stream's record over time, I can drop just the top level number of records there. If I wanted to break it down, say, by host name, we can do it by host name. Let's see here if I type it in the right field. And the ability to drag and drop for these different records to everything is interactive, so we can drill into our data quite quickly. We can pick different visualization types. So, you know, from area charts to donuts to even more advanced aggregations, our infographics like tree maps and donut charts are all possible at a click of a button. You can save these off and create your own dashboards. You can essentially add them to other types of visualization systems. We have a visualization system called Canvas, where more from usually a manager's perspective or a business perspective, you want to roll up the data. A lot of times, maybe you have a quarterly report where you talk about how many outages that happened across the platform, what was the mean time to resolution for those outages. Along those lines, a lot of times you'll dump the events into Excel, you create a chart, you import the chart into PowerPoint, you import a bunch of logos. Then you have to do that every quarter from that data. Elastic, since it's the place where you hold your data, will let you do those HPC high-level reporting events in a repeatable way. So in the Canvas interface, data can be created in picture perfect sort of, or pixel perfect sort of ways. You can use your own graphics, and it's driven by data underneath, and it'll update as data comes in. So you don't have to recreate those reports. So that's all the goodness from an operational perspective. Folks that are supporting those HPC platforms day to day with integrating alerting, integrated machine learning. But there's also that last set of folks who want to go look at the HPC performance data from a scientist's purview, usually data science purview. And the most popular tool set we have around those is a tool called Elan-D. And Elan-D is a wrapper around the Pandas Python data structure, which is a very popular way of data scientists using Python to do deep level textual based machine learning. And Pandas is a real simplistic interface. It couples closely with Jupyter notebooks for really good academic visualizations and repeatable playbooks. But most importantly, what Elan-D brings to it is the ability for Pandas to interact with data that's held in Elastic and not always brought into memory on the scientist's workstation. So it lets them work with much larger data sets than would be possible typically. And that's pretty important. It's pretty easy for them to get started. It's a Python pip install, or if you're using Conda, just straight up normal Conda Forge. It's been supported for quite some time. We're up to 7.13, and Elan-D has been supported since 7.6. It's open source, of course. It's up on GitHub, and with some pretty great docs. But just to dive into it a little bit before we wrap, data frame implementation. So integrating with the Pandas data frame, we do that by interoperating the Pandas data frame syntax with the DSL language, Elastic's query domain-specific language. And then we implement the different Pandas API subsets using query filters, aggregations, and a mixture of painless scripts. But the cool part is it's all happening inside of Elastic, and again, not on the scientist's desktop. So kind of at a real high level, how they map. So a Pandas data frame is an Elastic index. Row just means document. Pandas are columns or fields. And of course, from an index perspective, the ID/timestamp is the analogous term. But it being all backed with Elastic, you're going to have full text queries available with Elastic. You're going to have full text queries available, much richer than what you'd be able to get with Panda's native geospatial filtering, because the geospatial filtering components are analyzers as well as the relevance scoring. All these things are above and beyond what Panda's native would give to these data scientists. And that's going to allow them to get their work done and shuttle the data back and forth. So you can pull the data into the desktop if you'd like, or you can push data back out of the desktop with really simple, straightforward commands. But really what folks are mostly wanting to do is to train up models on those data, right? They're data scientists. They want to be able to take features, turn those features into vectors, and make those vectors something that can trigger either a textual alarm or something that's going to tag the data to enrich it and to make it more useful. And so they'll create those their own models, typically using pandas and Jupyter notebooks, figuring out what's the right data sets, usually using Elastic backed data to build up those training sets through queries. And then once they have their data models created, you can actually upload those models or a subset. So scikit-learn models from XGBoost to LightGB, and the ones that most folks use most of the time. So random forest classifiers and regressors are really the two most popular out there, and they're supported. So you can upload those models to run inside of Elastic. And when you do that, your model's running right next to the data. So there's no paging or pulling lots of data back over the stream. It's going to be a lot more performant, and it'll be managed by the Elastic Stack itself in the machine learning libraries. So I have threw a lot of information at y'all, but if you want to learn a little bit more, we have lots of different ways to receive more training. There's the Kibana and Data Ops Analyst is a great course for HPC operators, as well as the Elastic Stack Logging course, also a great course for folks who are operating HPC and adjacent platforms. and for folks who really want to get deep, learn how Elastic operates at the core level, be proficient in operating the platform at scale. There's a certified engineering perspective, and it's getting pretty popular. I know on the DoD side of the house, folks are really looking for certified engineers, so it might be a good thing to add to your resume. And we just want to say thanks. I appreciate you guys showing up late on a Wednesday afternoon. So thanks so much, and we'll see if there's any questions in the chat.